Welcome to this video on blockchain security. Today, we're exploring one of the most fundamental problems that blockchain technology was designed to solve: double spending. Understanding this concept is crucial to appreciating why blockchain is such a revolutionary innovation in digital currency systems. Double spending refers to the risk of spending the same digital currency twice in different transactions. Think about it this way. Unlike physical cash that you hand over and no longer possess, digital files can be duplicated infinitely. This creates a serious problem for digital currencies because without proper safeguards, someone could make copies of their digital money and spend it multiple times. Let's look at a concrete example. Imagine Alice has one digital coin worth $100. She sends this coin to Bob to pay for a coffee. But before that transaction is fully confirmed, she also sends the exact same coin to Carol to pay for a book. Both transactions appear valid simultaneously because they're just digital data. This creates a major problem: who actually received the legitimate payment? This scenario illustrates why double spending is such a critical challenge for digital currencies. Traditionally, this problem has been solved by using centralized authorities like banks and payment processors. These trusted third parties maintain a centralized ledger, which is essentially a record of all transactions. Every transaction you make is verified and recorded by this central authority. The bank checks your balance, confirms you have enough funds, processes the payment, and updates their records. This works, but it requires complete trust in that central authority. The question becomes, how can a decentralized network prevent double spending without relying on a central authority? This is the core challenge. In a decentralized system, there's no single entity to verify transactions. Instead, all participants in the network must somehow agree on which transactions are valid and which ones should be rejected. This requires a completely different approach to maintaining trust and accuracy. Blockchain solves this problem by creating a distributed, immutable ledger. Here's the key innovation. Every participant in the network has a copy of all transactions. No single person controls the ledger. Instead, transactions are grouped together and linked in chronological blocks, forming a chain. This distributed approach eliminates the need for a central authority while still maintaining a single source of truth that everyone can trust. The beauty of this distributed ledger system is network transparency. Because everyone can see all transactions, fraud becomes immediately visible. Every node in the network validates transactions independently, checking to make sure they're legitimate. Then, through a process called consensus, the majority of the network determines which transactions are valid. If someone tries to double spend, the network will detect the conflict and invalid transactions are rejected automatically. No central authority needed. Let's walk through how a transaction gets verified. First, when someone initiates a transaction, it's broadcast to all network nodes. Second, these nodes check if the sender actually has sufficient balance to make the payment. Third, if the transaction is valid, it gets added to a new block along with other pending transactions. Fourth, this new block is cryptographically linked to all the previous blocks in the chain, creating an unbreakable sequence. This process ensures that every transaction is verified by multiple independent parties before being permanently recorded. The consensus mechanism is what makes the final decision. The network reaches agreement on the correct order of transactions. When two conflicting transactions try to spend the same coins, the first transaction to be confirmed by the network is considered valid. The conflicting transaction is permanently rejected because the network recognizes those funds have already been spent. Once a transaction is confirmed and added to the blockchain, it cannot be reversed. This creates certainty and prevents anyone from going back and changing history. Let's revisit our earlier example with Alice. She tries to spend the same coin twice, sending it to both Bob and Carol. Here's what happens. The transaction to Bob gets confirmed first by the network and is added to the blockchain. When the network processes Alice's transaction to Carol, it checks her balance and discovers she no longer has that coin because it was already sent to Bob. The transaction to Carol is rejected due to insufficient balance. The blockchain has successfully prevented the double spending attempt. This all happens automatically through the network's verification and consensus processes. Let's recap what we've learned. Double spending is the core problem that blockchain technology was designed to solve. The distributed ledger eliminates the need for a central authority by giving everyone a copy of the transaction history. Network consensus ensures transaction validity by having multiple independent parties verify and agree on what's legitimate. And finally, cryptographic linking makes the ledger immutable, meaning once something is recorded, it cannot be changed or erased. Together, these mechanisms create a trustworthy system for digital transactions without requiring trust in any single entity. Thank you for watching, and stay tuned for more videos on blockchain security.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.